Good morning. My name is Monica and I'm working as an assistant professor in ABES Engineering College, Ghaziabad. Today I'm here to present a topic on design and analysis of algorithm consisting of two topics, that is fractional knapsack and traveling salesman problem. Moving on to our first topic, that is fractional knapsack problem. So the fractional knapsack problem states that if a thief is robbing a store, he can carry a maximal weight of capital W into his knapsack. Suppose there are n items available in the store and the weight of ith item is Wi and the profit is Pi. What item should the thief take? The main motive behind the stealing is the thief has to maximize the profit. So based on the nature of items, knapsack problem has been categorized into two categories. The first category is a fractional knapsack, where items are broken into smaller pieces. That means we are considering here a fraction. For example, if a thief is robbing a sugar, then he can take 1 kg sugar, 1.5 kg sugar, 2 kg sugar, 2.5 kg sugar also, 2.3 kg sugar also. But in case of 0-1 knapsack, the item can either be picked or not picked. For example, if he is stealing a TV, then he can only steal a TV, not its parts. He has to steal the whole TV alone. Moving on to the fractional knapsack algorithm, here we consist of a two array. First array is being indicated by V value. Another array consists of the weight of the items, where total capacity is being denoted by capital W, where I is equal to 1 to size of V, that is the size of weight value. We have to calculate Pi, where Pi is calculated as Vi divided by Wi. Now we have to arrange the PI in descending order. We'll take the items one by one and put it into the knapsack till there is a capacity to be filled into the knapsack. So fill the values along so on till the final capacity is reached. No longer will be added if the final capacity will be finished. So the running time complexity of fractional knapsack problem is order of n log n. So here we are considering 5 items having respective weight values. Item 1, I1, I2, I3, I4, I5 have a weights 5, 10, 20, 30, 40 respectively. Similarly, values are 30, 20, 100, 90, 160. Capacity of the total knapsack, that is capital W, is given by 60. So we have arranged these values into a tabulated format. Now we have to calculate the PI value, where PI value is calculated by VI divided by WI. So I1 is calculated as 30 divided by 5, that would give you 6.0. 20 divided by 10, that would give you 2.0. 100 divided by 20, that would give you 5.0. 90 divided by 30 would give you 3.0. 160 divided by 40 give you 4.0. Now we'll arrange this particular table into descending order of PI. We have arranged the values in the decreasing order of weight per value ratio. We'll pick the items in these particular order. First of all, we pick an item I1 as it is having a profit of 6 and a weight of 5. So it can be easily added to the knapsack having a capacity of 60 kg. Till now, we have a capacity 55 left that is to be filled. So another profit value is 5.0. So we'll get carrying next item, that is I3, having a weight value 20. So 20 plus 5 is 25, which is also less than 60. So we can take another item having a value 4.0 and the weight value is 40. After adding 40 to 25, the total capacity would be 65, that is greater than the maximum capacity of the bag, that is 60. So we'll take the fractional part of I5 item. See here we have taken first item as it is, second item full, third item we are taking as a fractional part. We need only 35 weight. So 35 by 40, the total weight is 5 plus 20 plus 35, that is 60. Now we have to calculate the maximum value, and maximum value can be calculated on the base of profit value. So we have calculated the profit value of first item, another item that is 100, another item that is 160, and its fractional part that is 35 by 40. So total cost is 270. Now, the next problem is traveling salesman problem. The traveling salesman problem says that a salesman has to visit a set of cities where he'll be starting from one city and has to return to same city by covering each of the city once. The main motive behind this is to minimize the total length of the trip. Suppose there are cities naming x1, x2, xn, where the cost is Cij, which denotes the cost of traveling from city I to city J. We have to find out the route starting and ending at x1 that will take in all the cities with minimum cost. For example, a newspaper agent daily drops the newspaper to the area assigned in such a manner that he has to cover all the houses in that respective area and has a minimum travel cost. So we had to find out the minimum travel cost. So for example, area assigned to agents where he has to drop the newspaper has been denoted by the vertices, and the path he follows is denoted by the edges, and the weight values are denoting the distance. So if there is a direct relation between two nodes, then we're writing the value, your weight value, into the matrix. So we have total H1 to H8 rows, H1 to H8 columns. H1 to H1, we do not have any direct edge, so value is 0. H1 to H2, we have a direct edge having a weight value 5. H1 to H3, we do not have any direct edge. H1 to H4, we have a weight value 6. H1 to H5, no direct edge, 0. H1 to H6, that is 4. H1 to H7, that is 3. H1 to H7 is, 0. And H1 to H8 is 7. So in this way, we'll fill the whole matrix, or we say adjacency matrix. Now, moving on to how a tour starts. Tour starts from the city 1, that is H1, and then select the minimum cost area. So H1, we have to find out those area which are minimum from H1. So out of 5, 6, 4, 7, we have a value of minimum is 4, which is at node H6. So we'll move to H6. In H6, we have to find out the minimum cost, that is 3, which is being observed from H7. Now moving on to H7, we have a minimum cost of 2. Now we'll move to 2, that is at H8. Now we'll move to H8. We have to find out the minimum cost, that is 4, which is at H5. We'll move to H5. Find out the minimum cost, that is 3, that is H2. We'll move to H2. We'll find out the minimum cost value out of 5, 2, 4, 3, that is 2, at a column number H3. Then we'll move to H3, that is 1 at the column number H4. In H4, that is our last node, we have to reach to H1. So what would be the cost of H1 would be treated as the last cost value. So the city tour starts from H1 to H6, H6 to H7, 8, H5, H2, H3, H4, and then H1. We have to find out the minimum travel cost. So we'll add those particular values in order to find out the minimum cost. That is 4 plus 3 plus 2 plus 4 plus 3 plus 2 plus 1 plus 6 would give you 25. So that would be the 25 would be the minimum cost from traveling H1 to H1 by covering each of the city once. Thanks.